right. So when it comes to that software that supports the additive manufacturing, what would you say are the most important best practices?
Well, okay, coming from like because I use multiple softwares, there isn't like, oh, is this the best software? Once you have an application defined, then you match the software. But then the important parts are, yeah, your parts have to be like solid. They need to be non-manifold. A lot of software like Mastercam or even desktop metal software will fix your files for you. Like, the file has to not have any holes in it. So you can make sure that it's watertight and basically, easy to 3D print. Like, for example, if your part has a lot of overhang, then the software should be able to prepare the support structure that's required to take care of that overhang. But it's not the same for if you're machining your part, where you as an engineer or a programmer needs to understand that, hey, this part has a lot of overhang, I need to change an angle. So there's a lot of front and back where the person who's working on the software needs to have adequate expertise with the software, but also have a very good engineering mind to be able to make the right decision on it.
Yeah, I really agree with you, Axel. Like before beginning to set like the best practice, I think the designers need and the engineers need to have like a very good idea about the process itself. Like, which process are they using? Are they using a powder bed fusion process? Are they using an SLA, an FDM? And the material as well, because each material has a different set of process parameters that would result in optimized part function. And on top of that, the whole idea of design for additive manufacturing and like embracing the whole idea of DFAM and understanding, like as Axel was saying, where to put supports, what's the maximum overhang, if these lattice are thin enough, if these lattice can be changed into different geometries. Yeah, so I think like in general, design for additive manufacturing.
Yeah, that makes sense. It sounds like that the best practices would really depend on what materials you're using, what the end part is, but incorporating the DFAM right from the start, no matter what it is, what type of additive manufacturing you're going to do. Makes sense. So what determines those features and capabilities that the software should have? And are there typical features and capabilities? I know you just touched on that a little bit in the last answer, but can you maybe go a little bit deeper into, the features and capabilities that the software should have, depending on the part?
Yeah, well, if you would like, I can talk about Mastercam A Plus, which is basically an add-on additive module to the Mastercam universe. In this software, you have control over every aspect of the machine. So we're talking about the angles, we're talking about the energy that's being used. Primarily Mastercam A Plus, we use it for DED based processes. So that would be lasers or wire arc. And in this, there's a lot of high energy. You need to melt your metal. You need to control that energy, and you need to be able to, make sure that the part is not colliding with your tool. I mean, also, you want to control every aspect of it, right? You want to control the flow rate of the gas that's coming out of the tool. You want to control the speed of the movement of the head. You want to control the angle at which you're kind of hitting your part. So all of these, and if you count the number of parameters, there could be like 300 parameters that you could control, and that's a lot of parameters. And that's just one technology, just DED with laser or wire. We kind of also couple this software with another software called CG Tech VeriCut, where we take all of this information, like the Mastercam will slice it, create a G-code file, and you throw it into VeriCut, where you run a simulation on it. and then you are able to determine that, hey, this code is exactly what it's saying it's doing it, and it can do it for like hundreds of machines in the market. So these are a typical way of working, where you prepare CNC code and then you verify it in a different software. Yeah.
Right.
Yeah. I'm actually gonna answer this question from a different perspective. I'm thinking more of the design itself and like some typical features I would like to use if I'm like designing for additive manufacturing is like if the software has the ability to create lattice structures. And I don't mean simple beam lattice structures, but like these complicated lattice structures with like that's bio-inspired or mimics some of the natural biology. I'd like to see like some features like topology optimization, removing the materials where it's not needed and creating this free form designs that are really suitable for additive manufacturing. Generative design, like Axel was mentioning at the beginning of our discussion, and how we can use artificial intelligence to generate these pre-mutations and like several designs that we wouldn't have imagined without the use of AI. And like, again, to resonance with what Axel was saying, definitely testing and validating. I like that Axel was saying testing and validating the printing process itself, but I'd like also to have a feature where I can test and validate my part, like a thermal analysis or CFD analysis or finite element analysis.
Well, what a terrific discussion we've had here today. Thank you both so much. Axel Fernandez, Additive Manufacturing Lead at CAD/CAM Consulting Services Incorporated, and Dalia Mahmood, Research Engineer at Metafold 3D. Both wonderful insights, and I can't thank you enough. And to our attendees, thank you for being with us. And until next time, stay curious.